Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Secondary, 2 degrees, carbon atoms in aromatic fused ring systems are carbons bonded to exactly 2 other carbon atoms. A 2 degrees hydrogen is a hydrogen attached to a secondary carbon, a carbon bonded to 2 other carbons. In the context of aromatic hydrocarbons, this classification applies to ring junction carbons and substituted positions differently from terminal positions. Moving on to the next step. Identify the structure. The compound is 2-chloronaphthalein. Naphthalene has 10 carbons in a fused bicyclic system. With Cl at position 2, 1 hydrogen is replaced by Cl. Moving on to the next step. Classify carbons in naphthalene numbering. Naphthalene carbons, positions 1, 2, 3, 4, 5, 6, 7, 8 are peripheral, each bonded to 2 ring carbons and 1 H in unsubstituted naphthalene, and positions 4A and 8A are the ring junction carbons, each bonded to 3 ring carbons, no H. Ring junction carbons, 4-8A, are 3 degrees carbons with no H. And for the final step, in 2-chloronaphthaleene, C2 bears Cl instead of H. The peripheral carbons bonded to exactly 2 carbon atoms are C1, C2, C3, C4, C5, C6, C7, C8. These are all 2 degrees carbons. C4A and C8A are 3 degrees, bonded to 3 carbons. Count 2 degrees H atoms. Among the 2 degrees carbons, C1, C8, C2 has Cl so contributes 0 H. The remaining 7 peripheral carbons, C1, C3, C4, C5, C6, C7, C8, each have 1 H that gives 7 hydrogen atoms on 2 degrees carbons. Verify other options fail. A. 2 too few. B. 5 incorrect count. D. 8 would require all peripheral carbons including C2 to have H, but C2 has Cl. Therefore, the correct answer is C. Therefore, the correct answer is option C.